Okay. So here's the problem. Write an efficient algorithm that searches for a value target in an M of X integer matrix. This matrix has the following properties. Integers in each row are sorted in ascending order from left to right. Integers in each column are sorted in ascending from top to bottom. Okay, so this is like this seems like a divide and conquer problem already. So, okay, we've got some input arrays, some examples. So I'm just going to pull these down, down here. Just look at them as code. So const matrix is that, and we'll say const target A. All right, and then we've got this other one, and then the output for this is supposed to be false. Or I'm sorry, true. And output for the other one is false. So I'll just drop that here. Const matrix B, and then const target B. Okay. Some formatting in there. All right, cool. And then this is output, should be false. All right. So have an array of arrays. I'm guessing this has to be, it says it has to be efficient. So we can't just loop through each individual array of arrays. Okay, so when we think about this, if I were to just like break this down so it actually looks like the matrix that we're going to be working with, let's just do that now. Okay, so it's going to look like this, right? And we can see, okay, so it's 1, 4, 7, 11. So it's ascending order from left to right, and then also ascending order from top to bottom. So low to high, basically. And we need to find some target value, right? So what's a intelligent approach to take for this problem? I think it would make sense to, okay, so I think we want to look at the first element in each subarray, so each row, and then maybe take a look at the first element in each column, so just all the first elements in the first row. And so given like our target here, we have 5, and so we're going to check, okay, so let's check all of these, right? So it's going to be somewhere, so as soon as we get to, so say we're looking at just the rows, we know that it can't be in any of the rows after line 20. So we can discard these 2 rows from our search pool. And then we basically just need to look through the individual column, the first value in each column. So 1, 4, 7, 11, 15. And I think we can immediately discard everything after the 4. So I guess it would make more sense because we would have to check, okay, is 7 greater than our target value? It is, so then we can just we can exclude everything from the element which was greater than our target. And so I guess a couple of questions here is, will the target always be contained in the input of arrays, or the passed in matrix? I'll just write that out. So let's write a question here. Let's see if it works. Oh, it looks like it doesn't want to work. Yeah, okay, so will the input array of arrays always contain the target value? Okay. And I've been going for about 5 minutes. I'm gonna set a timer for 35 minutes. Okay, you can see that down here. So the input array always contain the target value. There's a possibility that maybe it doesn't actually have the value. I guess another question would be, will the input array of arrays always have, or I guess, will the elements in the input array of arrays always have length greater than 0? So just meaning, like, is there always going to be some values? And also, I guess a general question for this would also be, will they always be integer values? I don't think that matters too much, and I think they might even state, yeah, they state it's an integer matrix. So I think that's fair, to assume that they're always going to be integers. This question I think is still valid though, with will it always have integers in it? I think it's fair to say that there will be. We know that, so then the rules explicitly stated here are rows are always ascending, and columns are also always ascending. Okay, and I'm wondering, I suppose I should write like another test case. Actually, let's just focus on the problem itself. I don't want to think too much about edge cases yet. I just want to see if I can solve this problem for these test cases. And then if our problem doesn't work, if our solution doesn't work, we will still have gone through the process, right? Okay, so this is an input array of arrays containing, I think it's fair to assume that it's going to contain one or more integers, of sorted integers, and as well as a target, k, target value, integer, and yeah, that's fair. And we just want to return true or false. Actually, that's okay. That's actually the point here, is that there isn't a 20 in this second array of arrays, so we can just make this look like a matrix, just for my own sake. Okay, we got that. That looks good. And so that's a possibility. And that's actually the point of the problem, is to check if there is in fact some value there. So it seems like we want to, I don't want to build, like, it wouldn't make sense to, like, I think my initial approach of thinking about discarding parts of each list and parts of each column makes sense. So I think that we need some way to essentially like step across the, so if I just grab these two and plop them up here, we need some way to walk across. So we want to check, I think I'll start with removing columns, actually. So I think I want to traverse the first elements. So we want to traverse the elements and access the first element only in each of our subarrays. And I'm just going to, as soon as that value is greater than, as soon as it is greater than our target, then we can just remove. And I guess there's a possibility, so I guess implicitly we can know that this isn't really a rule so much, it's just kind of a intuition here, is that the first element could technically be the target value. And so in that case, we would just want to immediately return true, because we've encountered the target value in our initial pass of the first elements in the subarrays. Okay, so I think what makes sense here is that we would want to start walking across, or start by traversing input array of arrays at index 0, and as soon as the current element is greater than the target value, target. We want to discard the rest, so stop, I guess, stop iterating, and exit loop. Okay, and there's also the possibility that like if the current element is equal to our target, then we can immediately return true. True, okay. And then we're going to want to do the same thing, and I believe we would be building an array at this point. I'm not going to worry too much about space complexity here, and I'm just going to focus on solving the problem, so this is not going to be optimized. But I think while we're doing this, we want to build an array. So let's build array by loop, and obviously we need to declare an array object, and we'll just call this maybe like under construction, okay, under construction, okay. So then we want to traverse that, and so for this first test case, right, our target is 5, we're going to be checking, okay, 1 is less than 5, 2 is less than 5, 3 is less than 5, and we hit 10, and it's like, okay, well, this is where we break point for rows, okay, and then as far as the breakpoint for the columns go, that's what our next step here is, and it's just going to be here, breakpoint right at the 7. So at the end of that, we would essentially just have this quadrant. So it would be this section, so 1, 4, 7, and I think I don't want, I suppose we could just like combine all the arrays and then check to see if some element is included. That's still of, I actually don't, I think is it n log n for like quicksort? I think that's right. N log n. Yeah, so that's not super efficient, but if it works, it works. I suppose for at least these test cases, I'm guessing I won't pass the leetcode questions, or the leetcode test cases. At least not all of them. But yeah, let's think about this. So we're building that array by looping. We can just that's kind of implied. So and then using under construction array, we want to loop over the first elements, first subarrays, first, I guess we'll just call it first rows, subarray, or first rows elements, and essentially performing the same operation here. So if current element is target, then we just can return immediately, return true immediately. Is equal to target, return true immediately, and then as soon as the current element is greater than target, we would want to stop iteration, so just exit loop. Okay, and then from there we're going to have this essentially, I guess we need to push all the elements left. Okay, so for this, it's fairly straightforward because we're just pushing the current row, right? And so if it is, so if current element is less than target, then we can push, let's make another line, then we can push entire row, right? So pushing the entire row into under construction. And then for this one, when it reaches that same condition, so if current target, or if current is less than target, then we want to push entire column into the under construction array. So how do we do that? What would that look like? So we definitely need, so for this portion, so we're just going to be traversing the first elements, or the first subarrays, I guess the first rows elements, and we need to have that index, right? Because we want to be able to push all the elements in each row, or I guess all the elements in that particular column, right? So like for this one, for example, we want to push the 1, the 2, and the 3. And at that point, that's all there would be in that array. So we would need to access the column. Okay, let's do a time 24 minutes. So we need to have the current elements index, right? And then we want to, for each element, for each subarray, so for each row, all the elements in that row at that specific index. So that comprises the column. So how would we do that? Let's think. Actually, I don't want to think too much about it yet because we're still kind of in the abstract algorithm portion. So we're pushing the entire column into under construction, and this is just, we haven't figured this out yet. Maybe let's see. I just want to grab this, and I just want to play with it for a second. So let's go here, declare it. Okay. So then matrix B. It's this, right? So maybe we just need to, I guess then for as soon as something is, so say we want, like, let's say we want all the elements in the first column. How would we do that? Matrix B, maybe for each, and we know we're going to have the index before this operation because we know we're going to have the index of, like, say it's 1 here, so index 0. So for each, I guess just row, we want the, I guess maybe just log, console log, row at that specific index. So for this, we'll say it's 0, and then we, okay, so that's, I don't know if that's efficient. It's still O of n. We're not doing any nested iteration. Well, this is, okay, this is technically nested. Maybe we don't need to do that. Maybe we just need to, I think I want to mutate the current array instead of pushing everything. I think I just want to slice as soon as, so I guess that would only comprise one operation as opposed to, I guess, one nested operation. Whereas if I'm pushing it for each individual column, that's quite laborious. So I think how we're going to do this, instead of pushing the entire column into under construction, I think we just want to mutate input array. And then so like what that's going to look like is we're essentially going to like from current index, we essentially want to upon each row slice from current index, or slice from 0 up to, but not including the current index, because the current index, the element of the current index was less than target, which is something that we don't want. Oh, and this is actually, okay, this is actually the opposite because we're not, yeah, okay, so it's if the current element is greater than the target, then we're going to mutate the input array by essentially, upon each row, slice from 0 up to but not including the current index. So we're mutating all of these subarrays in one operation, I think. Okay. So I think that makes sense. And so we're going to be mutating this. So it's clear that we can't use, I think it makes sense to just use, yeah, okay, so current element greater than target. And then we just need to exit the loop. Okay. Immediately exit loop. exit loop. Okay, so then up to this point, we haven't had an early return because like let's say we haven't found the target element has not been the first element in either of the columns or the rows. So at this point, we have this array, right? And again, I think this we need to change our operation here again. So if current is greater than target, then we're just going to do this exact same operation. So we'll just get rid of that, and we'll just place that here. Okay. Immediately exit the loop. All right. And then now that we have, so with mutated array, we essentially want to, I think we want to merge, I guess just flatten it. Maybe flatten and sort. I don't know if that would be efficient. I think it doesn't make sense to do that. I think flattening makes sense. So maybe flatten array into single array, into depth 1 array, and check if the target is included. I don't know if that's efficient. I think included is still O of n. I don't know the efficiency of flattening, but I guess we can find out today. All right, and then from there, we'll just check to see if it's included or not. So this is essentially our like return statement. So is included or not. Not. So this is just gonna be some Boolean return value. And yeah, I think that makes sense. So let's walk through this algorithm for the test cases. We've got a lot of time still. So we can just look at this one, and I'm just going to just paste that right here. We can get rid of that. Okay. And yeah, all right. So our first pass, we are going to be mutating this input array. So we're traversing, again, we don't actually need that. Start with traversing input array at arrays index 0. So we're just going to be looking here for all of these. And so we're saying, okay, the current element is less than target, so this is not evaluated. It's also not equal to the target, so that Boolean logic is not evaluated, or that conditional logic is not evaluated. As soon as we reach the 10, then we know that we no longer want anything below the 3. So I guess we would just need to take, we would need to, I guess, just discard everything here. So at that point, I guess, how are we doing that exactly? We want to mutate the input array in input matrix. So upon each row, slice from 0 up to but not including the current index. I don't think that makes sense for this. We just need to delete, I mean, a hacky way to do it would be just be to set the length to the current index -1, I think. Let's see what would happen if we did that to this matrix. We just do, so it's matrix B length equals, and let's say we hit the 10, so that would be index, so 0, 1, 2, 3. Okay, so if we just set it equal to the current index, and then we check matrix B, that does do what we want it. So it's a little hacky, a little not best, but I think it might be quite quick. Maybe. Again, not sure. So actually we don't need to do this slicing. We can simply set input, or I guess set matrix length to current index. And was it current index -1, or was it's just the current index? Okay, because that's where we encountered the value, which was greater than target. Okay, cool. Curious if that actually works. And then using under construction array, again, we're not using that. So I suppose we're just using mutated array. So now we have this, right? So that's where we're breaking there. So now we have this array of subarrays of length 3, and we're going to be traversing these elements. So let's check. Okay, so 1 is not less than target, or 1 is less than target. 4 is less than target. 7 is not less than target. It's greater than target. Okay. Yeah, okay. So then from here, we essentially just want to slice out everything here for all of these. So we're going to mutate the input array, and let's just check. So if we have like, let's say, actually, we literally have it already. We could just do maybe like matrix b dot filter. Then this would be, I guess we can just map it, honestly. Map, and we're dealing with we're dealing with rows right now. So we just need to take the current row and make it of length the current length. So row, I guess, okay, we'll do it this way. It will be return, or row length is equal to whatever the current element is. So I guess we need the index. I guess we would have the index, wouldn't we? Mutate input array. Upon each row, slice from 0 up to but not including the current index. So this is kind of the behavior we're emulating with the modifying the length property. Slice from 0 up to, so essentially I want to return the mutated row up to the current index. So we're say we're encountering that here. The current index is 2. And so if we were just to do row length is equal to the current index where we encountered this, then we would just want to return row, having mutated that row. And then we have that. And so then with that, so it's just this, I'm just going to grab that, put it up here. So now this is what our matrix looks like, right? Okay, so this is what our matrix looks like. And so I guess we would just be calling, we would essentially just be flattening this array of subarrays and checking if current, or if target is included in the elements in the resulting array. Okay, so I think that works. And yeah, let's get into maybe coding it up. We'll just get rid of this stuff and let's pull down our algorithm. Just grab all this. Oh goodness. Grab that. All right. Just gonna place it down here. All right. So first thing we wanted to do was start by traversing the input array. So let's write our function. What are we gonna call this? Maybe just find target, and our input is matrix and target. Okay, and we want to start by traversing the input array of arrays, and so that was just something like this. So for let's actually just use the for index and matrix length. All right, and so then this is going to be row. Do we want, actually, I don't think we want that. So let's just console log matrix at the current index. All right. And we'll just run that to see where it goes. So I guess we have to invoke it too. Let's grab our test cases. This output false, okay. And paste them right down here at the bottom. Okay, so matrix A, and we can just get rid of this. Okay, so have our test cases, we just need to invoke them now. So just do okay, so console log, oops. And this is find target, then matrix and target. Okay, and then matrix A, target A, matrix B, target B. All right. So let's just check to see that it's actually working. All right, and it is. It's just producing those, and so we're just iterating over the elements in the array and returning, or just logging the current row. So here we were going to just check. So I guess that's where we'll start. So we'll just do we'll just call this row start, or first const first element, and this is just going to be matrix at the current index, or matrix the current index at 0. Let's just log that. First element. All right. So if we run that, we should just see the 1, 2, 3, 10. Okay, great. So we have our first element. Now if we reference what we were doing here, we want to check if first element is equal to our target value. Then we just want to return true immediately. Otherwise, if it's not, then we need to check if current is greater than target. Then we immediately want to mutate the input matrix. So matrix length is equal to the current index. So that would be the current length. Okay, here we are. The current index, then immediately exit our loop. So just break here. And so let's just check what matrix looks like. Current is not defined because I did not declare it to be that name. So first element, first. Actually, let's just standardize that to current. I think it makes more sense. So current, and current. Oops. All right. So current matrix. Okay. So we run our code. We're seeing that mutation happening, right? So we got rid of those bottom 2 rows. So these 2 are now gone. So now it's working for that, and it did not yet work for the other one because we got to the end, so the very last first element in the row, 18, and it was not greater than. So we just preserved matrix, which is what we want. So we have that. So this portion of the algorithm is sorted. I'll just slice that and put it up here. Okay, so now we want to use this mutated array. So I want to loop over the first row's elements with a for loop. So for I matrix length. Okay, and then we can just get rid of this. If the current element is equal to the, oh goodness. The current element is equal to the target, we want to return true immediately, so it's the same situation here. And what are we looking at? We're looking at matrix at index 0. So we really only want to be iterating over the elements in the first element, which is a subarray of matrix. So that's what we're seeing here. Yeah, we can just do, so we're literally just going over this. So it would literally just be these elements, right? That's all we want, is just the first thing. So that's what we're gonna loop over. And matrix 0 at index I. And let's just log the current, whatever the value of current is at this point. So 1, 4, 7, 11, 15, which is what is expected for both of those. So that makes sense. That's what's being logged. So can I go back to what I had? All right, so if current is equal to target, we can just simply return true. Otherwise, if current is greater than target, then we want to set the matrix's length. Matrix. Oh, okay. So we want to set the. Okay, so can we do that? I guess we need to do that to each individual row that remains. So this is where the nested iteration is occurring. So we want to mutate the input array, and then upon each row slice from 0. So we can implement the same type of thing, but we have to do it to each individual row. So we'll take this matrix. Actually, maybe for the sake of, yeah, for the sake of a different approach, let's do it this way. Well, but this doesn't mutate. I guess we could declare like let new matrix, and then we can do new matrix initialized to the return value of this method invocation. So row, okay, so we want to be performing something on each row, and we simply want to return row from 0, so slice from 0 up to but not including the current index. Current index just being I. Okay, so we've sliced from 0 up to but not including the current index, and then we want to immediately exit our loop. So here we just want to just break, and then let's check and see what we're getting here. So return new matrix. Okay, let's see what we got. It's exactly what we wanted. And all right, so we got to the end. Okay, and then I guess we can just do this. Actually, we'll set it to an empty array initially. So then if in the case of the second one, it never creates that new, it never reaches these 2 lines of code here, because current was never greater than target, which makes sense because 20 is greater than 15. It's greater than all of these elements. That does make sense why that would happen. So we'll leave it as an empty array, and then we can just essentially check, does the flattened version, so new matrix flattened, does it include the target? I think it includes target. True and false, which is what we were expecting. And I'm curious to see if it actually passes in LeetCode. I don't know. Let's see if I can find the see if I can actually find the problem. But yeah, we finished in a little ahead of 40 minutes. Didn't do as much PDEC as I would normally do though. But yeah, that was a fun problem. I don't know if the mutation hack with length was the right move, but it seemed to work for those 2 test cases. So again, I'm very curious to see what LeetCode has to say about this, and maybe I can type something in the description for this video, because I think I'd like to keep this under 40 minutes. So yeah, thanks for watching, and I'll see you in the next one. Peace.